This video will cover the first structure topic, models of the particulate nature of matter. We'll start with a brief introduction to the particulate nature of matter, defining and classifying different types of matter. After that, we will explore 5 different techniques used to separate mixtures. Let's first talk about composition of matter. What is matter? Matter can be defined by 4 basic characteristics. It is composed of particles, such as atoms, molecules, or ions, occupies a volume in space, has mass, and its particles are in constant motion. It has been understood that matter consists of elements which combine to form substances, but elements themselves cannot be chemically broken down into simpler substances. IB states that elements are the primary constituents of matter, which cannot be chemically broken down into simpler substances. Throughout the video, I will highlight words that IB considers to be important in yellow. It is crucial for students to learn and memorize the definitions of these words because they can be tested on both the Paper 1 and Paper 2 external assessments. To continue, particles of one element are called atoms. These atoms can combine with atoms of another element in a fixed simple ratio. Let me explain this with an example. Hydrogen, with the formula H2, is formed by 2 hydrogen atoms bonded together. It is also an element because it contains one type of atom. It can also be called as a molecule because it has more than one atom. But it is not a compound because compounds are molecules made up of 2 or more different types of elements. IB states that compounds consist of atoms of different elements chemically bonded together in a fixed ratio. Let's look at another example. This is magnesium sulfide. It is made up of 1 atom of magnesium and 1 atom of sulfur. We can say that magnesium sulfide is a chemical compound because it consists of 2 types of element, magnesium and sulfur. Matter can be classified into 2 categories, pure substances and mixtures. Pure substances have a definite and uniform chemical composition and can be further classified into elements and compounds. On the other hand, mixtures are formed by combining pure substances that retain their individual properties. The key difference between pure substances and mixtures is in how they can be separated. Pure substances can only be separated in their individual constituents through chemical reactions, which alter their physical properties. However, mixtures can be separated into their individual constituents without chemical reactions, allowing each component to retain its physical properties. IB states that mixtures contain more than one element or compound in no fixed ratio, which are not chemically bonded and so can be separated by physical methods. Mixtures can be further classified into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures consist of particles that are evenly distributed throughout, such as salt water, where the salt is uniformly dissolved, making the individual particles indistinguishable. In contrast, heterogeneous mixtures have particles that are not evenly distributed. For example, vegetable soup is a heterogeneous mixture because it contains various substances like different vegetables and other components that remain visibly separate. As mentioned earlier, mixtures can be separated into their individual components by physical means. In this video, we will explore several techniques used to separate mixtures. Let's start with a simple example, a solid mixture of sand and sugar. How could you separate them? By understanding the properties of each solid, you can easily separate them. First, place the solid mixture in water. You'll notice that the sugar dissolves in the water while the sand does not. This process is known as solvation, or dissolution. By adding water to the mixture, you can separate the water-soluble substance, which is sugar, from the non-soluble substance, which is the sand. We can separate the sand and sugar using a process called filtration. First, you would need to pour the mixture of sand and sugar solution onto a filter paper inside a funnel. The dissolved sugar solution will pass through the filter paper while the sand particles remain as residue on top of the filter paper. So, after filtration, we will be left with the sand residue on the filter paper separate from the filtrate of sugar solution. We can then dry the wet sand by leaving it out for a few days to evaporate the water and obtain pure sand. Now, let's look at the filtrate of sugar solution that has successfully passed through the filter paper. To obtain pure sugar, the sugar solution undergoes a process called crystallization. First, the solution is heated in an open container, allowing the solvent, water, to gradually evaporate while the solute, sugar, remains behind. As the solution cools down, sugar crystals begin to form on the surface of the container. Over a few days, these crystals grow larger, eventually leaving the container filled with sugar crystals. This method effectively separates the pure sugar from the solution through the natural crystallization process. Now, let's consider another scenario: how to separate a mixture of two miscible liquids, like ethanol and water. Understanding the distinct properties of these liquids allows students to effectively separate them. Ethanol and water have different boiling points, which is crucial for their separation, using a technique known as distillation. By exploiting this property difference, students can perform distillation to separate ethanol and water. Let's examine the distillation apparatus and process in detail. The apparatus typically includes a heater, a distillation flask, a thermometer, a condenser, and a receiving flask. The separation process begins by heating the mixture of liquids. Once the mixture is heated, ethanol, having a lower boiling point of around 78 degrees Celsius, will start to evaporate before water, which boils at a higher temperature of 100 degrees Celsius. When the temperature of the mixture reaches approximately 78 degrees Celsius, ethanol will vaporize and rise through the distillation apparatus. Upon reaching the condenser, the vapor will cool and condense back into liquid ethanol. The liquid ethanol will then reach the receiving flask. Meanwhile, water will remain as a liquid form in the distillation flask because it has a higher boiling point and won't be able to vaporize around 78 degrees Celsius. This technique shows how the difference in boiling points works to separate mixtures of liquids. Let's take a look at paper chromatography, a method used to separate substances in mixtures based on their affinity for the solvent, which is the mobile phase, and the paper, which is the stationary phase. The separation depends on the intermolecular forces between the substances, the solvent, and the paper. To perform paper chromatography, immerse a piece of paper in a solvent, such as water. Next, place a drop of the mixture onto the paper. Over the course of a few hours, you will observe different components of the mixture moving along the paper at varying rates. More soluble components will move faster, while less soluble components will either move more slowly or remain near the drop point. This technique allows for the separation and identification of different substances within a mixture based on their individual solubilities and interactions with the paper and solvent. To wrap up, understanding these 5 techniques: solvation, or otherwise known as dissolution, filtration, crystallization, distillation, and paper chromatography is crucial for IB chemistry students. These methods give us the tools to separate substances effectively based on their unique properties, like solubility and boiling points. That's it for this topic. Stay tuned for more upcoming videos. And if you have any questions, comment below.